Good afternoon, everybody. A very warm welcome to all the attendees of the session and our distinguished panel. Let me introduce the panel first. We have with us Dr. Laviraj Gupta, who is a Pro Vice Chancellor of Lovely Professional University. He holds PhD in bioinformatics. He did his MTech in computer-aided design and interactive graphics from IIT Kanpur. He holds BE Honors degree of Mechanical Engineering from MITS Gwalior. He has flair for endless learning and has done 40 plus certifications and specialization on IoT, augmented reality, gamification, machine learning, deep learning, artificial intelligence, and the list is endless. His research areas are robotics, mechatronics, bioinformatics, IoT, AI primarily, and he has numerous patents to his name. Just to name a few, he has a Bagomoto powerless lift mechanism and Seta by Posture Proctor that was published in 2015. We welcome you, sir, in this session. Thank you so much for sparing your valuable time. Then we have with us.
Thank you, Dr. Gaurav Pushkarna. Thank you so much.
Then we have with us Madam Rachna Bajaj. She has been working in Department of Admissions with us since I think 4 or 5 years. She is an eloquent orator and has been visiting various schools for conducting career counseling seminars. Thank you so much, ma'am, for sparing your time here.
So much.
My name is Gaurav. I'll be the moderator of the session, and the agenda of today's interaction is choosing the right career or the stream. So the audience for this seminar is primarily the students who are appearing in the entrance test for engineering, and Dr. Laviraj would be throwing light on what are various options available, where you can guide your career through, and what are the career prospects, and how you can shape your career for your bright future. I'll hand over the session to you, sir.
Thank you, Mr. Gaurav Pushkarna. Thank you so very much. Today, in coming 25 to 30 minutes, I'll be talking about how we are redefining careers. There's a new era of new age engineers which is going to be there. The moment you will be graduating as an engineer after 4 years from 2022 or maybe 2026 when you graduate, there's a new age of engineering expectations that'll be around you. So I'll be actually giving you the gist of what kind of present scenario of engineering is happening around all of us. What will be the futuristic vision or futuristic dimension of this engineering as a whole? And then by virtue of discipline by discipline, I'll be talking about that what kind of projects our students have done. And finally, I'll be concluding at that how at LPU we make these engineering programs exciting, future ready, and making you a brilliant engineer, not for tomorrow, but for future. So let me begin with it. See, there is one world, one word which is ruling the entire world. When I say this thing, when I mean by this phrase, I'm very clear that there is one world which is actually the most commonly used kind of a word today, and which is prevailing all around us. And that word is nothing but smart. See, all the things around us, all the things around us are smart. Be it a phone is also smart. The camera is also smart. Your automobiles, even your motorbike is a smart motorbike because it works on embedded technologies. It works on high-end electronics, even while it is starting or even while it is actually running. It takes care of everything. The cars which you sit on or which you run on, they're very smart. The bridges, your bridges are smart. Your factories are smart. Your homes are smart. Even your television is smart. The cities are now becoming smarter. Almost everything around you is under the aegis of this word called smart. So let us look to it. What makes anything and everything smart? The capability of computation, availability of computation anywhere in any context. Everybody of us has got the capability to compute and is connected. Any device is connected, any service, any business is connected, any place you are connected, any time you are connected. Now, this connectivity makes things, philosophy, and the individuals smart. It all actually started with evolution, and now today we say that we are into fourth industrial revolution. The very first industrial revolution, it came when people started using water and steam to produce things. They used water and steam to mechanize their production capabilities and production units. The second revolution came when people started using electricity to produce things. This era of industrial 2.0, industry 2.0, gave individuals or gave business houses a capacity to produce in mass production. So first it was water and steam, then people brought in electricity to start producing things. The third era of industrial revolution, it came up with, you know, when electronics came into picture, information technology and electronics, they came into picture, and then the production became automated. So the first industrial era, first industry 1.0 was producing things using water and steam. The second, or industry 2.0, was producing things using electricity. That is wherein the mass production came into picture. And the third era was the era of including or bringing in electronics and information technology so that the automated production is there. But today, we are sitting in the era of Industry 4.0, where automation, data exchange, and digitization has completely changed the paradigm of production, of the way the things they work. I always say that earlier people were looking to how people were interacting with people. It was people to people interaction. Then people thought about how people are going to interact with devices. So that was people to device interaction. And now we are into the era of device interaction. Your two mobiles are talking to each other. Your mobile can talk to your laptop can talk to your fridge can talk to your washing machine. Those kind of things are happening. This can only be possible, made possible by just one word, and that is known as the cyber physical systems. Why I'm talking about this is that the engineers whom I'm talking to right now should be knowing about cyber physical systems. Be it you do your BTech in food technology, or you do your BTech in agriculture engineering, or electrical, or electronics, or civil, or mechanical, or aerospace, whatsoever it is. Everything would be encompassed with something called as cyber physical systems. I'll throw a light on this. The awesomeness is that right now we have got smart homes. Your homes are becoming smarter. Even your doorbell is now smart enough. So doorbell is smart. You are under the aegis of smart healthcare. Past 1.5 or 2 years, you've seen that how healthcare has completely changed its shape, contour, that everything has become smarter. Even your mobile phones would carry something to capture your oxygen saturation, or your pulse rate kind of thing, and it can actually give you that how stressed you are right now. So smart healthcare, whenever you walk on or whenever you move on highways, these highways are smart. They actually capture the density of the vehicles which are passing by, and then they can change the duration of the red light or the green light duration. The agriculture, we have seen vast changes in agriculture. Earlier, people used to sprinkle pesticides like anything, but now, based upon the requirement, based upon the need, based upon the quality and quantity of the soil and the moisture availability, the smart agriculture is completely changing the way. You are in the era where you have smart toothbrushes. That toothbrush can, while you're brushing your tooth, it can capture that for how long did you brush, for where you missed on brushing, and what kind of, it can give you the profile. You have seen, devices like Alexa, like Siri, which can control the complete home. You've got electric vehicles, smart electric vehicles. You've got some kind of vehicles which are unmanned vehicles. Now, this smartness is the need of the engineers of tomorrow. Thus, we curated engineering at LPU in such a way that this engineering has got a completely different focus. We think future because we have built transdisciplinary. I'll come to this word and explain it to you. What do you mean by transdisciplinary? We have built transdisciplinary research domains. Each of your study would have different domains which would be heading towards different domains put together. A mechanical engineering student can talk to an agriculture student so that he can increase the efficiency of agricultural implements. A computer science student can talk to a food technology student, and they can really build applications which are meant for foodies completely. When we say think technology shift, see, technology is shifting rapidly. It is shifting with lightning speed. For those shifts in technology and to make engineers ready for that technology shift, we have created advanced laboratories so that the technology of future can be experimented in today's context. When we think of expectation, so think future, think tech shift, think expectation, you've got the best of the faculties available who are going to deliver the content which is going to make you future ready. When we say think of careers, we have got loads of industry associated programs now available for you to join in. We have got Siemens participating in mechanical program. We have got Intel and Texas Instruments participating in electronics program. We have got whole load of participation of industry. When I say participation of industry, it's not just simply building the curriculum. Even the industry experts are going to deliver you the courses, making you future ready. We have got center of excellences available with us. When we say think beyond, now this thing beyond is completely based on your readiness of engineers of tomorrow. Now, this engineers of tomorrow, the basic expectation would be that you should be ready with the experiential learning. You should be doing things on your own, not just simply the bookish knowledge, but the knowledge by which you can do things on your own, by which you can hand over the spanner and open up the entire engine of a vehicle and reassemble the entire engine of vehicle. Thus, what we do is we are trying to make you think smart. Because as I said, everything in this world, or the most prominent or the most preeminent word in this world is smart. So by thinking future, by thinking technology shift, by thinking expectations, by thinking careers, and by thinking beyond, we are going to make you think smart. And for that reason, let us see how various discipline students at LPU, what kind of projects they do, so that we can very well gauge and judge that how they are future ready, how they are thinking smart, what kind of things your seniors have done in order to make themselves ready for tomorrow. Let's see. See, for electrical and electronics students, I'm just giving you the gist of what all has been done. During the times of COVID, they curated a very plain, simple device. We call it as 20 seconds for life. Now, this 20 seconds for life can be attached to any of the soap dispenser. We all know that WHO says that you need to wash your hands for at least 20 seconds. But nobody takes up the wristwatches or wall clocks to the washroom. So this device, actually, the moment you press the nozzle or the dispenser's nozzle, it actually runs the music for 20 seconds so that you are very, very well known. And you know, these things which I'm talking about, see at the bottom of my screen, the Times of India featured this device in one of its major stories. All the things, these things, A, they are done by students of the disciplines which I'm talking about, and B, they're very well taken up by the media, very well taken up by the industry, and now they are going to be produced. We also, during these COVID times, you know, what was happening is that in the COVID wards, who you will send to collect the trash, whom you will send to collect the so you need a smart dustbin. So what the students of electronics and electrical engineering they did, they they crafted, they fabricated, and they created a smart dustbin called LE. Now this LE is voice control. As you control your devices through Alexa, this is voice control, and this can work on a pre-navigated path. So if a patient sitting on bed number 56 calls, "LE, please come and collect my trash. I've got I've got something available with me which I need to throw into the dustbin." The LE would go to the bed number 56, collect the dustbin. So it was reducing or completely negating the human presence. And these all are, see, this is Coin DX, a very prominent kind of worldwide, media house, which has published the story of Ellie. This was just the tip of the iceberg. I was talking about the electrical and electronic students which they did. Now I'm going to talk about what students of mechanical, automobile, or aerospace have done, and you can participate in such, innovative projects in times to come. The students have created a solar bus. You might talk to me. Solar bus is a very common kind of thing, but this solar bus is completely driverless. It is so smart that it can work, or it can navigate from point A to point B without a driver. You just simply, it's a driverless. It's something which the students of automobile mechanical engineering, they join hands together, and they actually crafted an autonomous solar bus. So from going from one place on campus to another place on campus, you do not have a driver. You just sit in the bus, and the bus is moving from station A to station B. So it is negating what all the kind of pollution, and it is negating all the kind of accidents which may happen. The students of aerospace using the drone technology, and as I said, that students of aerospace can talk to students of agriculture. The students of agriculture gave a problem statement that there is a problem in actually sprinkling the pesticides or fertilizers in the field, and the fertilizers or pesticides which are sprinkled in the field goes waste. So what these both the group of students sat together, and they crafted something called as flying farmer. Now this flying farmer can take up the payload and could sprinkle the fertilizer exactly in the quantity in which it is needed. It is not either overdoing the sprinkle of fertilizer, or nor it is actually underdoing the sprinkling of the fertilizers. Now this is the power of two things. One is that you are becoming future ready. When you are actually studying in a discipline and you are doing projects like this, and you are getting associated with different other disciplines also, you absolutely become a smart, which is the need of the hour. You become smart, and you become what? Future ready. You are not becoming an engineer for today. You are not becoming an engineer for maybe tomorrow. You are becoming an engineer for coming next 2 decades. You will craft solutions. The students of biomedical and bioengineering, they crafted a oxygen, a very oxygeno, a, a mask which is very effective and is algae based. They crafted a ultraviolet racket so that, during the COVID times, if you buy some groceries from somewhere, you can bring it at home and just span and swan over these items, these racket over the items, and they'll be completely, virus free, making it virus free. Why I'm talking about this is that this is the power of futuristic thinking. This is the power of transdisciplinary thinking. The students of civil engineering, basically, they study evolution, that how the stages of civil engineering has come up, from crude tools to use of machines, and then finally use of softwares. And today, the civil engineering students would be completely ready by digitization and digitalization, and they'll be ready to create smart homes out of smart materials, the materials which can actually change their metamorphosis, which can change their physicochemical properties. This is something which we do. And how do they do it is, in the very first year, they started they start building their own house, the model of a house. They do it. It is not cardboard kind of a house or something like that. It is a true foundation work which they do, true columns and beams which they create. Now, this is what we say experiential learning. And owing to this experiential learning, we have created marvels like Metal Magna. It's a 55-feet giant structure, and this only a combination of mechanical engineering, civil engineering students can sit together and do, because the mechanical engineering students would know how to actually weld, how to create the basic linkages and do things. And the civil engineering students would do all the structural analysis. I'll give you an example that these are certain very basic things in chemical engineering. What the students of chemical engineering have done is they have created a purifier, an air purifier, which they call it as Go Algae. And see, again, the Times of India. And what they have done is they have collaborated with ICER. So we not just simply look to collaboration within the LPU kind of thing. We look to the collaboration with outside world as well. You are going to collaborate with national reputed labs. You're going to collaborate with uh, best of the foreign university, the professors and the students, to craft something wonderful and meaningful. See, I wanted to give you a gist because engineers of tomorrow would not belong to a discipline. Say, for example, even if you're doing your chemical engineering, you should be very well versed with something called as artificial intelligence, something called as machine learning, something called as data analytics. Because even though you must be very good at chemical engineering, but until and unless you know what data analytics can do to you, you'll not be able to survive in times to come. So what our approach to success is that we have moved on from multidisciplinary, wherein actually two disciplines or three disciplines they are participating remotely to a particular topic. We moved on to interdisciplinary, wherein actually they are participating enjoiningly. But today, what we talk in LPU about is about transdisciplinary research, where the various disciplines are actually annihilated, where they are mingled, where they are mixed, where they are brought in together to a level of equitable participation. And that would is going to make you the best of the engineers. So I'll give you the cut above the rest. The cut above the rest or the cut in engineering as a career for for you to move out in the times to come would be that we talk about learning by doing. You need to learn by doing things. See, studying a book, reading something would make you just concept ready, but would not make you the smart problem solver. So we believe in learn by doing. And we have understood that until and unless you do projects, and projects, theories are very well needed. But if you are doing a project around that theory, you learn it for a lifetime. All the challenges which you face during your projects, while you are fabricating a project. Say, for example, you're welding. two rods. And see, theory will always tell you that these kind of welding defects may come, these kind of welding challenges may come, but that may be very limited. But when you are actually welding two rods, then you are actually facing the true forms of welding defects, the true forms of challenges which one can encounter or which one can experience during the welding of two things. So projects are the key with us. We explore transdisciplinary domains. All the projects which I've shown you is people from hygiene, or people from food technology sitting with computer science, or computer science students sitting with electronics and agriculture people. They are creating solutions which are more viable, which are more societal, which are friendly, eco-friendly, and which are actually low cost. We will let you participate in loads of international events. Why do we do so? That until and unless you see the competition outside, be it national outside, be it international outside, you'll not be able to know and judge what others are doing, how others are thinking about a problem statement. So we'll let you participate in lots of international events so that you understand the technology shift, where the technology is going. We will ensure that your digital presence is very strongly created. Digital presence meaning thereby that your profiles, be it a GitHub profile or Bitbucket profile or maybe your LinkedIn profile, says not about what generally or socially you do. It will talk about what technically you do, how well you have made yourself groomed into technology, not the technology of today, but the technology of tomorrow, the technology of 2026 or 2030. We'll let you to create the co-create the magic, because as we say that learn by doing is there. You are going to do loads of projects, not with your classmates, but you're going to do your projects with the students from various disciplines. If you belong to chemical engineering, you may do a project with maybe fashion technology, and why not? You may do a project with electronics, and why not? So all in all, what we talk about is we strongly believe in thinking smart, and we believe in think big. I welcome you to this world of thinking big, thinking smart, and I'll be now open for any kind of question and answers, either after this session or maybe after the session delivered by Ms. Bajaj. Thank you, everybody.
Thank you so much, sir. Thank you so much for throwing the light beautifully on various aspects of engineering streams and more importantly, highlighting the need of transdisciplinary approach. Thank you so much, sir. I'm sure all the participants are now well aware and enlightened on this issue. In case anybody has a question, can you can type your question in the Q&A box. Uh, so there's a question, sir. Student wants to know exact difference between mechanical engineering and aerospace.
Okay. So mechanical engineering is very basics of applied mechanics. When you have applied mechanics, be it friction, when you implement or apply that friction to run your car using the serrations on the tires, and the scratching of tires onto the road. That's one part of mechanical engineering. Mechanical engineering is more towards linkages, more see your cycle chain and sprocket kind of thing is a linkage kind of a mechanism. It is more about engines. It is more about heat, like thermal. You have combustion engines, but aerospace is more towards jet propulsion. It is about jet engines. It is about the thrust, or it is about the push needed for a missile to be launched. It is about the trajectory of the missile. How do you make that missile more efficient and more long distancing? It is more towards that if you want to use or extend your mechanical engineering know-how, if you want to use combustion to run an engine, that's mechanical engineering. But if you want to use that combustion to to propel a to propel a satellite or to a space rocket, then it becomes aerospace.
Thank you so much, sir. Thank you so much for the wonderful answer. Uh, Now I would like to invite Madam Rachna Bajaj. She would be primarily covering the infrastructure that we offer here. And more importantly, since you have taken this entrance test and the result of LPU Nest was declared on 5th, so now you are supposed to rank your preferences on your admission portal. Okay, so she'll be demonstrating you how to rank your preferences for your engineering programs in your admission portal. Over to you, ma'am.
Okay, thank you so much, sir. I hope my screen is visible.
Yes, it is.
Yes, thank you so much.
Turn it on slideshow mode, please.
Okay,
It's not in
just a
slide.
second. I hope now it is visible, sir. In slide mode, slideshow.
No.
There's a slight delay actually. There's a slight delay. It is going to come.
Or when you have shared your screen, you have shared the whole screen or just one single window. That can be the issue.
Nothing else, sir. I've just shared my screen. Nothing. I'll share once again. Just give me a second.
Yes, perfect.
Now it is visible. Thank you so much, sir. Okay, so good afternoon, everyone.
First slide, please.
I'll just share a quick glimpse of the infrastructure which is being offered to our students and where you will be probably joining in the near future. So first up, we have some amphitheaters. We have around 3 to 4 amphitheaters where we generally conduct some cultural events like Nukkad theaters or some other activities for the students. The Shanti Devi Mittal Auditorium, I would like to mention that it has a capacity of more than 2,400 audience in this indoor auditorium, being the largest in this region. So next up is an outside view of our university mall. I would rather say that this mall has all the facilities, necessary facilities, except the theater. So all the necessary facilities like the electronic gadgets, or if you want to dine in, or if talk about gymnasium and other facilities are available in our university mall. And yes, not to forget a bowling area. I suppose it would be a favorite pastime for our students. So yes, one of my favorite, which is the Shanti Devi Mittal Indoor Stadium, which has several sports facilities like Olympic level swimming pool, an indoor Olympic level swimming pool. Then we have 12 badminton courts for our students, a shooting area. So a glimpse of our academic labs and computer labs. So this is a glimpse of our iMac lab, which is available inside the campus. Cisco lab, and a beautiful picture clicked by one of our students, and another mesmerizing night view of our LPU campus. So I'll be just moving towards a practical.
They're not moving.
Chorus, sorry, is my slide visible?
Yeah, it's visible.
So next, I'll just shift to the demonstration of our LPU nest. So once you have filled your LPU nest and received your result, so you will be landing on this page where you will be filling your preference. So once you open this page, you can see this option on the right side, rank your preference. So once I click on this button, Yeah. So on this page, you will just have to select few of the subjects which you have studied in your 12th or intermediate. So let's say if I have studied non-medical with English, physics, mathematics, and chemistry as my subjects. So this preference will be visible in front of you once you submit your subjects. So you just have to rank your preferences. Let's say my first preference is computer science and engineering, a regular program, computer science and engineering. So I'll just click on it and drag it on the top. So this becomes my first preference. Let's say my second preference is computer science and data science. So this will be my second preference. Similarly, my third preference becomes computer science and user experience. So you can just submit your experiences by dragging your programs. And once you have selected your preferences, just click on the submit icon on the right side of the screen. So are you sure you want to submit your preference? Yes, I am sure that I want to submit my preference. So yes, thank you for your information. I have been successfully submitted. So this is how you submit your preference. And over to you, Gaurav sir. If I have missed anything, please let me know. Else I have demonstrated the students how they can fill their preference.
Yes, I think it was pretty clear that the demonstration was perfect. So it is a request to all the students that who has not filled their seat preferences till now, kindly do it because the last date is 8th and the allotment letter would be issued on 10th. So thank you so much all. I would be winding up the session now. In case you have any queries, you can shoot a mail at admissions@lpu.co.in email ID. We'll be getting back to you within 24 working hours or so. Thank you so much to the distinguished panel. Thank you so much, Dr. Laviraj Gupta, Vice Chancellor of LPU, and Ms. Rachna Bajaj, Division of Admissions LPU. Thank you so much, sir. Thank you so much, ma'am.
Thank
So I'll
you.
be ending the broadcast now. Thank you so much, students.